Hello, my name is Fabien Kunis. I'm a PhD student at the University of Sofia St. Clement and also I'm a teacher at Bojan Penev High School in Sofia. I teach physics from 7th to 12th grade. On behalf of Associate Professors Maja Gaidarova, Evelina Kotseva, and myself, I would like to thank Professor Mario Mitu and everyone who is involved in organizing this conference. My PhD thesis is for cooperative problem solving under the supervision of Associate Professor Maja Gaidarova. Therefore, I would like to give a talk about applying cooperative activities in high school physics course during hybrid model of learning. I would like to thank to my co-authors Maja Gaidarova and Evelyn Koster for their great support. Let's start with some important definitions to make sure we understand the terms in the same way. Collaboration is a coordinated, synchronous activity that is the result of a continued attempt to construct and maintain a shared conception of a problem, Rothschild and Teasley. Cooperative learning is a situation in which two or more people learn or attempt to learn something together, during work. Cooperative problem-solving competency is the capacity of an individual to effectively engage in a process whereby two or more agents attempt to solve a problem by sharing the understanding and effort required to come to a solution and pooling their knowledge, skills, and efforts to reach that solution. This is from PISA 2015. There are many studies that show the benefits of cooperative learning. Let's briefly mention some of the benefits. Students demonstrate academic achievement. Cooperative learning methods are usually equally effective for all ability levels. Cooperative learning is effective for all ethnic groups. Students' perceptions of one another are enhanced when given the opportunity to work with one another. Cooperative learning increases self-esteem and self-concept. Ethnic and physically or mentally handicapped barriers are broken down, allowing for positive interactions and friendships to occur. Also, cooperative learning results in increased high-level reasoning, increased generation of new ideas and solutions, greater transfer of learning between situations. We've seen that cooperative learning has many advantages, but of course, everything has its challenges. Cooperative learning has many challenges and it's not easy to implement in the curriculum. In order to successfully implement cooperative learning, it is necessary to have a proficient teacher. Unfortunately, many students have group hate. Group hate is defined as a feeling of dread that arises when facing the possibility of having to work in a group. Usually, their individual performance in the group suffers, and in turn, the group as a whole suffers. There are many factors that lead students to this experience. Some of the more crucial factors are a past bad experience, overuse of cooperative learning, simply liking to work alone. These factors are very serious and it's not easy to overcome. In order to overcome these factors, it is necessary for the teacher to have the knowledge and skills to do so. Wolfing is defined as students who don't take responsibility for their own role, even if it is the smallest role in the group. Students expect that cooperation will be fair for everyone within the group. In order for cooperative learning to be fair, the workload must be shared equally within the group, or at least shared based on students' abilities. And everyone must participate. Many students fear that this will not take place. This leads to the students developing group hate. To avoid this situation, the teacher must be aware of the process and take steps to ensure that the workload is divided fairly. This can be a difficult task. It is often difficult to understand which students are wolfing while the project is taking place, unless other students in the group bring the problem to the attention of the teacher. It is a common practice to have the group self-assess after the project is complete. Students often will assess their group positively in hopes that they will in return be assessed the same way. This often leads to inaccurate assessments of the group. Here again, the role of the teacher is very important in order to obtain an objective assessment. Very often, groups are unable to achieve sufficient cohesion because they fail to manage conflict effectively. The students are not usually in a group long enough to develop good group cohesion and establish effective ways to resolve conflict. The problem is that most students have had a negative experience in groups and consequently are apprehensive to get into such a situation again. The role of the teacher is to show the advantages of cooperative learning and that cooperative learning will be useful for everyone. Negativism exists in almost all student groups, whether it be because of past bad experiences, concerns about how the project will play out, worries about group members wolfing, or not knowing how to effectively manage conflict that may arise within the group. A key role is played by the teacher, who must overcome these challenges. This will lead to students having better group experiences and learning how to work better in groups. With cooperative learning, the textbook is used only as an instructional supplement. So it is necessary for teachers to create additional materials for the students. Usually these materials are made from scratch because many instructors' manuals offer limited suggestions for group activities. Creating these new materials can be very time consuming. So not only are teachers spending a large amount of time implementing this new way of learning, but they also have to create new materials. Since students have to generate answer or information within their group, work time may take longer than traditional lecture. Because of this additional time, teachers may be unable to cover the same amount of curriculum as before when they use teacher-directed class discussions. Unfortunately, many times the quality of the work is compromised in order to teach the entire curriculum. Peer instruction is a great method for cooperative learning, developed by Professor Eric Mazur. Professor Mazur has made many resources for peer instruction, which are very interesting and useful. So try very briefly to describe the procedure. Teacher poses questions based on students' responses to their pre-class reading. Students reflect on the question. Students commit to individual answer. Teacher reviews students' responses. Students discuss their thinking and answers with their peers. Students then commit again to individual answer. The teacher again reviews responses and decides where more explanation is needed before moving on the next concept. Peer instruction is a very effective method for cooperative learning. During this school year, I use this method in a cooperative learning environment. That is both face-to-face learning and online learning. I was even amazed at how easy and convenient it is to implement this method in online learning. But let me briefly explain how I implemented and used this method during the school year. The technologies I mainly used were Google G Suite for Education, and especially Google Docs and Kahoot. We, the teachers in Bulgaria, were forced to use either Google G Suite for Education or Microsoft Teams and Office. There were many complaints from parents that teachers use different technologies and this confused the students. So my school decided to use Google G Suite for Education. But I was surprised to learn that Google Docs allows the principles of peer instruction to be integrated easy and convenient. Before the beginning of each lesson, I posted materials on the topic and asked questions on the topic using Google Docs or Google Forms. Students answered questions or remarked what they didn't understand. Based on these answers and notes, I created the conceptual questions to ask during the class. The technology I used to ask questions and polling is Kahoot. This proved to be very effective during online learning. Teachers are used to judging by the reactions of the students, whether they understand the material and whether additional explanation or additional examples are needed. But during online learning, it is very difficult to see the reactions of the students. Therefore, I find this method very useful and and at the same time engage students in the learning process. To make the most of my time, I asked a series of questions. I then divided the students into groups through breakout rooms. Then I asked the same questions, and what I noticed was that the number of correct answers increased significantly, which means that the students were able to better understand the material, communicating with each other. Jigsaw is also very popular and interesting method for cooperative learning. There are different variations of Jigsaw, but here I'll focus on Professor Ransom's concept. To implement this methodology, the teacher must take the following steps. Introduce the strategy and the topic to be studied. Assign each student to a home group of 3 to 5 students who reflect a range of reading abilities. Determine a set of reading selections and assign one selection to each student. Create expert groups that consist of students across home groups who will read the same selection. Give all students a framework for managing their time on the various parts of the task. Provide key questions to help the expert groups get information. Provide materials and resources necessary for all students to learn about their topics. Bring the students back into their home groups. Ask each student to present her or his segment to the group. Float from group to group, observing the process. Remind students that home group members are responsible to learn all content from one another. At the end of the session, give a quiz on the material. Jigsaw is also a very good method for cooperative learning. I used Jigsaw less often than peer instruction. I used this method in a hybrid learning environment. It also turned out to be easy to implement Jigsaw in an online environment. The technologies I mainly used were Google G Suite for Education and Kahoot. I usually use Jigsaw when I give larger research projects. For example, colonization of Mars. I divide the class into groups, usually groups of 3 to 5 students. I divide the topic into separate parts. An expert group is created for each part. Each expert group receives materials and is also free to find materials on its own. In the online environment, each expert group works in separate breakout rooms and makes notes in Google Docs. The students then return to their home groups. If you are in an online environment, again in different breakout rooms. Students take notes and discuss issues in Google Docs or Google Jamboard. Finally, the whole class comes together. I ask them questions and they answer using Kahoot. On this side, I would like to briefly describe the main tools I use during online learning. I find breakout rooms extremely useful. They allow us to divide the class into separate groups and give different tasks to each group. I highly recommend using breakout rooms. Google Docs has many cooperation options. Students can create and edit documents together, make comments, and have discussions. The use of different Q&A responses significantly improves online learning and increases student engagement during the lesson. There are many apps like Kahoot, Socrative, Quizzes, and so on. Padlet is a free online tool that is best described as an online notice board. Padlet can be used by students and teachers to pass notes on a common page. The notes posted by teachers and students can contain links, videos, images, and documents. Flipgrid is a website that allows teachers to create grids to facilitate video discussions. Each grid is like a message board where teachers can post questions and their students can post video responses. VideoAnt is a web-based video annotation tool. Teachers can use VideoAnt to add annotations or comments. Well-hosted videos. Edpuzzle is a teaching tool used to place interactive content into pre-existing videos and also to embed either open-ended or multiple-choice questions, audio notes, or comments in a video. At the end of the semester, students evaluated their cooperative activities. The students were from 9th and 11th grade. The total number of students is 68. A 5-point Likert scale was used for evaluation. The following scale was used: not at all, no, neutral, yes, very much. The following questions were asked. Did you like the physics course? Did you like the team projects during in-person learning? Did you like the team projects during online learning? Did you like the software tools? Would you like to have more team activities? On the next two slides, we see the results from 9th and 11th grade respectively. The number of 9th grades was 49. The study involves students from a class with major in mathematics and students from a class with major in humanities. Physics is the second major subject for the students in the math major class, and they have additional classes in physics. The students in both classes give a positive evaluation of the questions asked. There is a less interest in physics among students in the humanities major class. But the students from both classes give a very positive evaluation of the team activities. The positive evaluation of team activities in a face-to-face form is higher than the evaluation of team activities in an online environment. The difference is small. The number of students in 11th grade was 90. The students were only from a class with a major in mathematics and a second major in physics. Since last school year, 10th grade is the last grade in which students are required to study physics. The students give a positive evaluation of the question asked. But the students have a more positive evaluation of the team activities. We see again that the positive evaluation of team activities in a face-to-face form is higher than the evaluation of team activities in an online environment. But again, the difference is small. It's time for my main conclusions. The resources described in the report provide teachers with effective tools that could be implemented in face-to-face and online physics education. Students give a very positive evaluation of the cooperative activities during their learning, both in face-to-face and online environment. Team activities are a method for increasing interest and the motivation of students for the acquisition of quality and long-term knowledge and skills in the field of physics and STEM education. Thank you. On behalf of Maja Gajdarova, Elena Kotzev, and myself, I would like to thank the Research Fund of Sofia University for their support. It is a great pleasure and honor to participate in this conference. I'll be happy to answer your questions, so feel free to contact me. I wish you all the best.